Now we start the execution of this KMP algorithm. First we will have a dry run for the KMP this prefix function, and then we will talk about KMP matcher in the next section. So we compute prefix function as under. So first of all we take the pattern, and this is all about pattern guys over here, so nothing to do with the text. So we take the length of the pattern and we store it in a variable m. And here and then we have those pi of 1 which is initialized to 0. So and then k is also 0. So right now we start with this situation, and in this table you will also see what we can have. We have a queue at the top, so that is from 1 through 7, and then the pattern which is AT, AT, AC, A. And this algorithm is working on the pattern itself in order to try finding the occurrences of some character before it. So for example, we see that we have A at position number 1 and we have 3 another A at position number 3. So in this case we can keep track of it and we can reuse that in order to avoid extra comparisons in when we do this matching. So Q is moves 1 through 7s. So these are actually we start with Q2 as far as this for loop is concerned. So here we just initialized length of P is equal to 7, pi of 1 is equal to 0, and K is equal to 0. Now we move to the next step. So we initialize and we start it and we come with Q is equal to 2 to M. So right now we are at Q2. So at that position we have T right here. So this is our Q2. So since our K is not equal to 0, we won't go over here. Right now our K is equal to 1, and P of K plus 1, which is 0 plus 1, so P of Q actually, so 0 plus 1, which is right now this first character, and we are comparing with P of Q right now. So P of Q is actually right now Q is 2, so we are comparing first and second character right now. So they mismatch, so we won't go here too, and here we put the value of K and we put it in pi of Q right now. So right now we have pi of Q is equal to 2, so at that position we will put a 0. So after this first step we have Q is equal to 2, K is equal to 0, and P of 0 plus 1, which is P at position number 1, that was A, and it was not equal to P of Q at 2, which is T. So in that case we will substitute a 0 over there. Then we move to the second step. So right now since K is not equal to 0, we won't go there, and step number 5 and 6. Now we look into P of K plus 1. So right now our K was actually in the previous step the K was 0. So we put 0 plus 1 which is P of 1, and our Q in this step is actually the Q is incremented in this for loop. So now we have on Q is equal to 3. So on third position in the pattern, which is A, it matches with the first position which is A. So in this case we increment the K, and so K goes 0 plus 1, K plus 1, and in pi of Q we put this value of K which is 1, and we put that 1 over there in our table. Now we are in step 3. Here as we have seen in the previous step, our K was 1, and right now our Q is equal to 4. So we are incrementing in the for loop, so Q becomes 4. So we are comparing P of K plus 1, which is P of 1 plus 1, and is it equal to P of Q plus 4? Yes, it is. And the top we will also see, since our K is greater than 0, but P of K plus 1 not equal to P of Q, this condition number 5 is not true, so that's why we won't go there. Rather 7 is true, because here we see that P of 2 at the second position we have a T, So that matches with P of Q is equal to 4. That's also a T. So in this case, we increment the K. That is, now K becomes 1 plus 1. It becomes 2. And we put that value of K as per this number 9 in pi of Q. So that goes to 2. So we put that 2 over there. Pi of 4 now is equal to 2. This 4 is coming from, in the table, this 4 represented with the line which is with the Q. The row starts with the, it's labeled as Q. So at the fourth position, we will put a value of 2. Now we move to the fourth step. So here we have Q is equal to 5 and K in the previous step that was 2. So we will use that value, and now we will compare K plus 1, which is actually 2 plus 1. So P of 3, we have a over here, and that will be compared with P of Q is equal to 5. So do they match? What about condition 5 and 6? K was greater than 0. Yes, we will go there and check first. But P of K plus 1, that was P of 3. We have the nucleotide A, and we are comparing with P of Q. Was that not equal to as per 5? No. So we won't go there. Is it equal to? This position number 5, we have A, and position number 3, we have A. So yes, it is equal to. So we will go into the lane 7 of this algorithm. We will update the K. So K becomes 2 plus 1, 3. And we will take that value 3 and store it in pi of Q. So right now pi of Q is equal to pi of at position number 5. So we will put this value 3 in position number 5. Okay guys, so here is the step 5. So now our Q, which was incrementing as far as this for loop was concerned, so Q becomes 6. Now our K is equal to 3 as we had in the previous step. And now we need to compare position number 3 plus 1, which is K plus 1. K was 3, so it is 3 plus 1. So we need to compare the fourth element. Over here it was T, and we need to compare with C, which was present in the sixth position. Are they equal? No. So we are in lane 5. Do while K greater than 0. Yes, it is greater than 0. K is equal to 3. And P of K plus 1, which is P of 4, is not equal to P of Q, which is actually P of Q6. So in this case, they are not equal. So what we do is, we will take the value at pi of K, and we will update the K with that. So right now, at that position, we have the value pi of 3. That was at position number 3, we have the value of 1. So K will be updated to 1. So we put that value pi of 6 is equal to 1. So step 6, now our Q increments to 7. K in the previous example was 1. So now we are comparing the second element here, P 1 plus 1, which is actually in the algorithm it was K plus 1. Was that equal to or not equal to? So P at position number 2, which was T, is it equal to this value at position number 7, that is A? No. So we will stay in this condition 5 and 6. And then we will increment the K with the pi of K. So at that position, the pi of 1 was actually 0, since our K was 0. So at pi of 7, we will store a 0. So in this way, we have computed this prefix function, and we will use this information when we will do our matching.